Alright guys, I'm going to make a quick video for you to help you get through these gas laws practice problems. The first thing I want to do is identify the relationships between pressure, volume, and temperature. So according to our man Chuck, his law states that volume is proportional to temperature when there is constant pressure. That means, or I could spell, that means that if the temperature goes up and the pressure doesn't change, and the volume has to increase as well. So as volume increases, temperature does as well. If volume increases by a multiple of 2, if it's doubled, then temperature is doubled as well. It's also written as V cool, almost sideways infinity, 8 thing going on, T. That symbol means proportional to. Boyle said that, let me zoom in, there we go. Pressure is inversely proportional to volume. So if pressure increases, then volume has to decrease. If pressure is doubled, if it's multiplied by 2, then volume has to be divided by 2. So as pressure goes up, volume goes down. And the way we would write this out is P proportional to 1 over V. That means the inverse of volume. And the last one, Gay-Lussac. He said that, pressure is proportional to temperature. What this means is as the pressure increases, temperature increases as well. You can write that out as P proportional T. The way that these problems work is you have to remember that the ratio of volume to temperature is going to be the same the whole time. The proportion of pressure to temperature or pressure to volume are going to be the same the whole time. So if we were to look at volume and temperature, V1, 1 stands for time 1, over T1 has to be the same as V2, volume 2, over temperature 2. So if, for example, volume 1 is 5 liters, temperature 1 is 100 Kelvin, you don't know V2, and temperature 2 was 200 Kelvin. That means that you set this up, always use your units. whatever this side would equal out to is going to be the same as this side. You can cross multiply, where you multiply the 5 liters times 200 Kelvin and V2 times 100 Kelvin. You can do that. It's a little bit longer. I personally like the workaround of just getting V2 alone and multiplying 200 Kelvin to the other side. Multiply by 200 Kelvin. That cancels that. So 5 liters times 200 Kelvin is going to over 100 Kelvin will equal volume 2. 200 times 5 is 1,000. To write out the units now, do liters, multiplication sign, Kelvin, over 100 Kelvin equals V2. Give division, and you end up with 10 liters equals V2. So as you can see, that our temperature doubled, so our volume did the same thing. If you're working with Boyle's law, the equation you want to use is, you know what? Let me clean. No, that's fine. The equation you want to use is P1 times V1 plus P2 times V2. You can see that here we're using multiplication instead of division. And this is Boyle. And for Gay-Lussac, it is pressure 1, P1 over T1, temperature 1 equals pressure 2 over temperature 2. So real quick, I'm going to go through a few of these and show you how to do them. And then it's going to be up to you. So number 1, the variables in this one, we have pressure. I'm going to do some highlighting so you can see what I am looking at. And temperature. So the first thing you should know is that we need to change all of our degrees Celsius to Kelvin. Second thing you need to know is which formula we're going to use. Because it is pressure and temperature, in this case we use Gay-Lussac's law, which means you're going to be using P1, P1, P2, and T2. Here are what each one of those means. Pressure 1 is 55 atmospheres. It tells you that in the question a container holds a gas at a pressure of 55 atmospheres. P1. Temperature 1 is negative 100 degrees Celsius. Convert Celsius to Kelvin, you add 273. So negative 100 degrees Celsius plus 273 gives you 173 Kelvin. And this is T1. Right now, pressure 2, we don't know. So we're trying to find out. The temperature 2 is 200 degrees Celsius. 200 degrees Celsius plus 273 can equal 473 Kelvin. That is T2. For this one, because we're using Gay-Lussac's, we're using P1 over T1, P2 over T2. Going to do some magic with that equation. So if we just set it up with all the variables, P1 over T1 equals P2, T2. P2 is what I'm trying to find. That means I need to move T2 out of the way. Do that, I multiply both sides by T2. Cancels out on the right and just adds on to the left. So now this becomes P1 times T2 divided by T1 equals P2. Then you plug in your data. So 55 atmospheres times 473 for T2. Make sure you get that Kelvin in there for the units. And 173 Kelvin for T1. You solve this out, it will give you P2. Now you didn't notice, I just took a moment to do this math really quick on a calculator. You're welcome to do that. Kelvins are going to cancel out, and you're going to wind up with 150.38 atmospheres P2. I'm just going to work my way through number 2 and do each step and go a little bit faster. I'm not going to read out what I'm doing, but follow along best you can. All right. So I'm finding volume and pressure. Volume pressure is going to be Boyle's law, which is going to be P1 times V1 equals P2 times V2. So I just figured out what each of my variables is going to be. So real quick, I'll set up my equation. Do some movements to divide both sides by P2. I can get V2 alone, which is what we want. That'll cancel out. That will lead us to pressure 1 times volume 1 divided by pressure 2. Now equals V2. Plug in the math. You can see how I've plugged this all in. Then I math out on a calculator. And we expect that the volume will drop since the pressure is increased. Atmospheres cancel out, and we end up with 0.375 liters for volume 2. All right, let's check out one more that will match up with Charles' law. Spoiler alert. So we have volume, we have temperature. We know the volume is at a lower temperature. The first thing I'm going to do is figure out what all of my variables are. I have volume 1, temperature 1, volume 2, temperature 2. You guys don't have to wait for this. Now you'll notice that I didn't have to convert into Kelvin because they gave us the information in Kelvin. If I set up my equation, wrong variable, T1 of T1 equals T2, T2, move T2 again, and you'll have T2 divided by T1 equals T2. And because the temperature went down, in this case you expect the volume to go down as well because, as Charles said, they're proportional. So real quick, I'll plug in my numbers. So we end up with 0.5 liters times 150 Kelvin divided by 300 Kelvin will equal volume 2. And that will come out to, should come out to 0.25 liters. I'm just going to double check. Oh, I said 0.25, not 0.52, because that's something I would do. Anyway, the answer comes out to 0.25 liters is equal to volume 2. The other 9 problems are up to you guys to do. I believe in you. And